Right, okay, here we go. So, session 23, moving on to a different chapter. We're looking at trigonometry, and we're going to look at some graphs today, what the trig graphs look like, and then using those graphs and another sort of technique to solve some trig equations. Right, okay, so let's go straight into it. Right, okay, so by the end of the session, you really need to know what the three following graphs would look like if you were to plot. The first one, y equals sine x, we need to know what that looks like, we need to know what y equals cos x looks like, and we need to know y equals tan x. We've got three graphs and we need to know what they look like pretty solidly, and we need to just know those fluently, okay? And the best way to build them up is to consider a circle, what we call the unit circle. So a circle that's got a centre of 0, 0, and a radius of 1, okay? So it's got a centre of the 0, 0, radius 1, and we're going to call that height. So any point on the circle has a height, well, that's just the y coordinate, and a width, x, okay? And let's just call that angle theta there, okay? Right, now before we start looking at the graph, let's just consider that triangle and what sine theta would be, okay? So sine theta we'll start with. Now sine, remember, is O over h, opposite over hypotenuse, and in this case, the opposite's y, the hypotenuse is 1, y over 1 is y. Okay, so we've got sine theta equaling y. Right, let's do the same for cos theta. Now cos is adjacent over hypotenuse, which is x over 1, adjacent x, 1 is the hypotenuse, so it's just x. And we've got tan theta, which is O over A, TOA in SOHCAHTOA, which in this case is y over x, okay? So I've ended up with sine theta equaling y. I've got cos theta equaling x on my triangle, and I've got tan theta equaling y over x. Okay, now we're going to draw the graphs, and I'm just going to draw this to the side. Okay, I'm going to start with the sine, so I'm going to do that one in blue. And what we're going to do is I'm going to call this theta, and I'm just going to call this one, for example, so this is just going to be what sine theta is. So this is sine theta in blue. We'll start with sine theta in blue. So when theta is for sine, let's just look at sine first. So when theta equals 0, so imagine that triangle when theta is 0, what's y going to be? So when theta is 0, it's just going to be a straight line, isn't it? Because there's no angle there, which means y, the height of that straight line, is 0. So when theta is 0, here, sine theta will also be 0. So because y is 0, so sine theta will be 0. When theta equals 90, let's go to 90. So at 90 degrees, it's going to be straight up there. Well, the height of that, well, your y coordinate is 1. So in that case, it's going to be 1. So at 90 degrees, we get sine theta being 1, okay, and it's 0 there. At 180 degrees, so it's a full turn all the way around anti-clockwise, it's going to be there, and your y is 0 again, okay. So it's going to be 0, and then at 270 it will have swung all the way down to there. So again, your y this time is going to be minus 1. Sorry, at 270, not 180. At 270, it's minus 1. And then it repeats. So at 360, it's back where it started when sine theta is 0. And you get a nice smooth curve, and it's called sort of a sine wave, this. And that is, if I just make that blue, that is our sine. Okay, so our sine graph, the blue one, would look like that. And it does repeat into the negative as well. So it goes into minus numbers as well. Right, let's look at cos, and I'll do green for cos. So we'll do the same again on the same graph. So when theta equals 0, well, let's just draw that in. When theta is 0, what's your x value when theta is 0? Well, your x is 1 there. So that means cos theta is equaling 1. Okay, there. because x is 1. Right, let's do when, so I can start it off the graph there. When theta is 90, or when theta is 90 up there, x, because we're looking at x this time, x is 0 in that case. So in this case, when theta is 90, cos theta will be 0. So I can put a 0 there. At 180, if I swung it all the way around, our x coordinate is going to be -1 there. So when it is 180, it's -1. You can probably see a pattern occurring here. At 270, it goes back to 0, and at 360, it's 1. So our cos graph is going to make a nice move. It looks very similar to the sine graph. It's shifted over. So our green is going to be cos theta. Okay? Again, it goes into the negative as well. -90 there. So that's cos. And the final one, tan. I'm going to do this one in pink. Okay, so when theta equals 0, you've got to be careful here. When theta is 0, we said x, well, y over x. Well, when theta was 0, y was 0, wasn't it? And x was 1. And 0 over 1 is 0. So I can plot, my first point is 0. Now, tan gets a bit funny when theta is equal to 90. So when theta is equal to 90, y over x, well, y at 90 was 1, and x at 90 was 0. So, yeah, I just need to put that was equal to 1 there. And 1 over 0, well, that's a bit of an error there. In fact, so we can't do that. That means it's it's going to tend to infinity. So we have an asymptote. So what we have at 90, it never actually touches 90. It just gets really, really close to 90 and gets bigger and bigger and bigger. Okay, so the tan theta one, and we have a similar situation at 270. You can sort of think about what y over x would be at 270, and it goes through 0 at 180. So the pink one there is tan theta. Okay, if you weren't quite following that, all you really need to know is what the graphs look like. You need to know that the sine one is the blue one, the cos one is the green one, and the pink one is the tan theta one. Okay, so that's what the graphs look like, and that's going to be helpful a little bit for when we solve equations. We're going to have a look at some equations now. So solving trig equations. Solving trig equations, okay, and we'll look at straight in with an example. So e.g. 1, solve 10 sine theta plus 3 equals 0, 4. 720 greater than or equal to minus 360. Okay? Right, okay, so we're solving this, and you might be able to have a go at this yourself, so just pause it, and maybe have a go, and then I'll go through it in a second. Okay, right, step 1, you must make sine theta the subject. Sine theta, make sine theta the subject. Okay, so in this case, if I do that, I've got 10 sine theta plus 3 equals 0. I can minus 3 from both sides to start with, and then divide by 10. So sine theta equals minus 3 tenths. That's step 1, okay? Step 2, do the inverse theta. So in this case, theta, and you would have known this from doing sort of SOHCAHTOA questions, finding the missing angle, you do the inverse sine on both sides, okay, on your calculator. So let's just do that on my calculator. So I get the calculator up, I just go shift sine, and it was negative 3 tenths. Bracket, and I get minus 17.5. Okay, so there's 3 significant figures. So I get theta equals negative 17.5 degrees, okay? And at this stage, usually you probably would have stopped, actually, but we've got more solutions, okay? We've got more solutions. And if I look back at my question, this is what's important. It's all the solutions between minus 360 and 720. So what I'm going to do, I'm going to show you a tip to do this afterwards. But how this works is I'm going to draw the graph of sine in that range. And I know the sine graph, if you go back to the top, starts at 0. It's going to be, doesn't have to be super accurate. That's 360. So that's 360. I need to go up to 720. It repeats itself. So I'm going to do the same again. 720. That's going to be 540. And it goes in the negative direction all the way to minus 360 there. It's symmetrical, so everything's symmetrical about ourselves. And that is sine theta, and that was theta, okay? And what I've actually done here, I've solved the graph. I've solved my question is to solve sine theta equals negative 3 over 10. And now if you remember from the graph, it goes from 1 to negative 1. And negative 3 over 10 is the same as like negative 0.3. So negative 0.3 is about there. And what I've done here, if I draw a line across, I've got one solution there. I'm going to have another solution there. I'm not going to have any more solutions there because it doesn't cross. But I'm going to have another solution there. I'm going to have another solution there. And I'm going to have two more over here. One here and one here. So my final answer here, I'm actually going to have 6 answers. There's 6 pink arrows there. And I've only created one from the calculator. The calculator's only good enough to give me one. And I've got one of the solutions straight away. And the one I've got, if you have a look at the graph, is that one. That is the one I've got, and that is 17.5, negative 17.5. Okay? Now, to get all the others, I use the symmetry of the graph. Because I know this distance here, I know that distance there is 17.5. Okay? And I can use that to help me get all the others. So if we start from this one, that distance there is also going to be 17.5, and I know that that is negative 180. So my next answer, that first one, is going to be minus 180, and it's backwards, so plus 17.5, and that'll give me my next solution. So I'll just do that. Plus 17.5, and I get negative 162.5. Okay, so negative 162.5. Okay, that gives me that one. If I go over to the right side, well, again, that is 17.5. All of these are 17.5. So the next one along is going to be 180 this time, plus 17.5. Okay, which is 197.5. That's given me that one. So I've now got the first 3. The next one here, well, you can probably have a think about this. That distance there is 17.5. So this next one's going to be 360 minus 17.5. Which is 342.5. Okay, and then I've got 2 more. I've got another one over here. Now, usually in exam, you wouldn't have this many. This is just an extreme example, just to get you thinking about how all the possible solutions. So this one's 540 plus 17.5, which is 557.5. And the last one over there is going to be 720 minus 17.5, which is 702.5. And they are all my solutions. I've got 1, 2, 3, 4, 5, 6 answers there. Now I can check that. If I go back to the very start, and if I just do sine, let's pick the 342.5. This should be about negative 3/10. It's not going to be perfect because I did a bit of rounding, you'll remember. It wasn't exactly minus 17.5. If I press equals now, you see it's pretty much negative 0.3. And I could do that with all of them. Let's check another one. 557.5. And again, very close to negative 3/10. Okay, so that's how I answer these questions. Okay, so I draw the graph out and then I just look at symmetry. I get the first value from the calculator. So I've got to get the first value from the calculator. And then all the others, I use symmetry of the graph. Okay. Right, now this is the tick box. You can either draw the graphs, and if you're comfortable drawing the graphs, look at its symmetry, great. But some people prefer to just remember a rule, and there's a tick box here for doing that. So if we look at sine theta, now it's different depending on which one you're doing. Okay, so sine, cosine, and tan. Right, so sine, cosine, tangent. You get the first value from the calculator. okay? And in this case, it was minus 17.5. You get the second value by doing 180 minus the first value, okay? So I'm just going to put that in. So first value from the calculator, second value is 180 minus the first value. And then at that point onwards, you just plus or minus 360 degrees until you're outside the range, okay? Right, when we do an example, I'll explain what this means. But for the moment, because this box is going to be really helpful to copy down. Right, cos, first value, is very similar to sine. First value you get from the calculator. Second value you get from 360 minus the first value. Okay, so instead of the only difference here is it's 360 rather than 180. Okay, and you do the same again. Once you've got those two, plus or minus 360 until you're outside the range of values. Right, tan, really easy. You get the first value from the calc, and then you just plus or minus 180 until you're outside the range. Okay, so tan's a little bit different. Okay, now that box there is really going to help you when we do some examples, okay? Right, let's do 2 more examples and then I'm going to let you go. Have a go at some questions yourself. Right, so EG2. Solve cos theta equals 0.3. Now, cos squared theta equals 0.3. That's the question. Cos squared theta equals 0.3. Give answers to 2 significant figures. And I want the range between 360 and negative 180. Okay, so that's the range we're looking at. Right, note, this is really important to note down. Cos squared theta is the same as cos theta squared. That is just the same thing. Okay, so cos squared theta means the same as cos in the brackets squared. Right, so how we answer this question? Cos theta, I'm just going to rewrite it as that. So I square root both sides, so cos theta will equal, now remember it's plus or minus, it's really important here. So if I square root 0.3, I get, well, I'm going to leave it exact, root 30 over 10. So I get plus or minus root 30 over 10. So I've got 2 possible answers. So let's look at option 1, when it's positive, root 30 over 10, okay, or cos theta equals negative root 30 over 10. And let's look at the left-hand side first. So the first value, remember, first value I get from the calculator, and I'm going to actually draw this as a table to help it keep it all neat and tidy. So I'm going to go shift cos answer, because that was root 30 over 10, and I get my first value is 57 to 2 significant figures, 57 degrees. Now my second value, I go back to my tip box, and the second value is 360 minus the first value. Okay, for the cos one, 360 minus the first one, so it's going to be 360 minus 57, which is 303 degrees. So I've got 2 answers there, and then for each one I plus or subtract 360 until I'm outside the range. Now if I add 360 to 57, that's going to be too big, okay, because it goes beyond 360. If I minus 360, it's not in the range. But whereas the 303, if I add 360, no good. But I can also subtract 360, and that will be inside the range on this side. So if I subtract 360, minus 360, I'm going to get a negative 57. So that is inside the range. Negative 57 is between minus 180 and 360. So I've got 3 answers there. Right, I'm going to go back and have a look at the other side now, because it could also have been negative. So the first value I get from the calculator, as before. Let's get the first value up. So shift cos, this is negative root 30 over 10. And I get 1, 2, 3, 120 to 2 significant figures. Remember my second value for cos is 360 minus the first value, so 240. Right, now I have to add or subtract 360. So if I add or subtract 360 from 120, it's going to be outside the range either side again, so I'm not going to bother with that one. This one, 240 minus 360. Let's just check that. Again, if I add 360, it's going to be too high. If I subtract it, I get negative 120, which is inside the range. So I can also do that value minus 360, which was negative 120. I have therefore got 6 answers to this question. My final answers are going to be 57, 303, minus 57, 120. This was also 2 significant figures, remember, and 120 again. Well, I've included 120 twice, so I don't need to do that, actually. So I can just ignore that one because I've already included it. Okay, so I don't need to repeat any twice. And I'm going to do a quick check. So remember right at the start, it was cos squared theta equals, what was it, let's say 0.3. Let's try minus 57. Let's see if that one works. So what I mean by that is cos negative 57. And if I square that, I get pretty close. Remember, it's not perfect because I rounded. And I can do that if I just keep changing my... Let's try 120. Hopefully that gives me something similar. It gives me 0.25. Again, it's because of the rounding. Because of my rounding errors, they've been compounded a little bit. So 2 significant figures is not ideal. Let's try 240. Because I've rounded it, it's not ideal, yeah. So that's going to give me the same, okay? So that is correct there. It's 2 significant figures. Right, let's do one more example. So let's do one more and then you can do some practice. So I want you to solve EG3, solve 2 tan squared theta plus tan theta minus 1 equals 0. And the range for this one is between 360 and negative 360. The range for these questions is really important. Right, now this is what I call a secret quadratic. It's a quadratic equation because remember tan squared theta equals tan theta squared. Okay, that's just what mathematicians do, that because we're a bit lazy at times. Right, step 1 for these is let tan theta equal something like y. Okay, so if you let tan theta equal y, I can then rewrite the equation. So instead of 2 tan squared theta, I've got 2y squared, and instead of tan theta, I've got y. And I solve this normally. It's a quadratic. I can do lots of different ways. I'm going to try and factorize it. So 2y over 2. The 2 numbers multiply to negative 2 and add to 1. So it's going to be plus 2 minus 1. And if I do the other one, I get y plus 1, 2y minus 1. Okay, equals 0. So I can solve that. Y equals negative 1 or y equals half. Okay, and I just replace it back because y was tan theta. I can now just say, well, tan theta equals negative 1 or tan theta equals half. Okay, now I just go to my little table. The first value I always get from the calculator. So let's do the left side first. If I go shift tan negative 1, I get minus 45. Minus 45. Now tan is the easiest one because you just, if I go back to my tip box, it is just adding or subtracting 180 until I'm outside the range. So I've got that's my first value. I'm just going to subtract 180 until I go outside the range. Minus 180. I get minus 225. That's going to be within my... If I minus 180 again, I'd be outside the range. Remember the range was this. You have to always refer back to the range at the start of the question. I could add 180 though, couldn't I? So I just had minus 45. If I add 180, get 135. And I could probably add 180 again. Add 180 again. And I get 315. Yeah, that's still in the range. The next one's going to be bigger than 360, so I'm going to stop there. So I've got 4 answers from that side. If I go over to the right side, this time I get the first value by doing shift tan 0.5, which is 26.6. Yeah, 26.6. I'm going to do the same again. So I keep subtracting 180 until I'm outside the range. So first one, next one, minus 153. That's inside the range. I'm going to do it again. Minus 333. That's also in the range. And I could have added 180 as well. So if I do 26.6, add 180, I get 207. So to three significant figures, 207. If I add 180 again, well, that's going to be bigger than 360. So I'm going to stop there. I've actually got 8 answers here. So my answers to this question, I've got minus 45, minus 225, 135, 315. I've got 26.6. minus 153, and all of these will work in your calculator if you type them in. So if I go right back to the start again, let's just pick, say, minus 153. So minus 153, so it's 2 tan minus 153, all of that squared, plus tan 153, minus 1. Hopefully this gets close to 0. Yeah, again, the problem is only because of rounding, but yeah, that's pretty close to 0. So I know that one's good, and I could go through and test all of those if I wanted to. Okay, right. This is it's quite a tricky topic. This one. You do a lot of this at A-level maths. Anyone doing A-level, you're going to be at a big advantage by working through this session slowly. And what I want you to do now is page 173 from the AQA textbook. I just want to do question 2, 5 and 7, okay? Question 2, 5, 7. And next time we're going to look at some identities, trig identities, which is super fun. So I'll see you next time. Well done for listening this time. And see you in session 24.